Yes, good morning, children. Today I am going to explain the properties of determinants. So, see these properties, these are very important properties, and we can apply these properties in the examples. While solving the example, we can use these properties of determinant. The first property is the value of the determinant remains unchanged if its rows and columns are interchanged. So it means that if we interchange the rows into columns and columns into rows, the value of the determinant remains same. Okay, so I have considered this determinant here. This determinant is 2 minus 3 5 6 0 4 1 5 minus 7, and by expanding this determinant along the first row, I get the value as minus 28. So value of this determinant is minus 28. Now we'll interchange the rows and columns. Okay, so this is the symbol to write interchanging rows and columns. So R interchanging C. So when we interchange rows into column, this is the first row, 2 minus 3 5. It will become the column. So 2 minus 3 5 is the column of the new determinant. 604, second row becomes the second column, third row becomes the third column, and now we have interchanged the rows into columns. And now simplify this, find the value of this determinant, expand along. I have expanded this determinant along the first row. So it is 2 into 0 minus 20, like this, minus 6 into 21 minus 25, and plus 1 into minus 12 minus 0. Okay, so this value is also minus 28. So this is the first property, that even if we interchange the rows into columns, the value of the determinant remains same. The value remains same. Okay, the second property is, if any two rows or two columns of a determinant are interchanged, then the value of the determinant changes in sign only. So now if we interchange any two rows or any two columns, the value gets changes into the sign only. Only the sign will get changed, the value remains the same. So this same determinant I have considered, the value of this determinant is minus 28. Now interchange the first and second row, interchanging R1 R2. This is the symbol to interchange. So interchanging R1 R2, this is the first row and the second row. So first row element will be the second row element in the next determinant, and the second row element will be the first row element. So I have interchanged the first and second rows. Now again expand the determinant, find its value. Okay, it is 6 into, see this is 6 into 21 minus 25, middle term is 0, third term 4 into 10 plus 3. Okay, and the value we get as 28. So value of the determinant remains same, only the sign has changed. It changes in sign only. So if we interchange any two rows or any two columns, this is true for two columns also. If we interchange any two columns, then also the value changes in sign only. This is the important property of determinant. Then the third property is, if any two rows or two columns of the determinant are identical, then the value of the determinant is 0. Means if any two rows or two columns are same, the elements of any two rows or two columns are same, means the rows or columns are identical. Any two rows or columns are identical, the value of the determinant becomes 0. So I have considered this determinant. In this determinant, observe these elements carefully. Here the first column is 301, second column 2 minus 1 4, third column is also 2 minus 1 4. So which two columns are same? C2 and C3. So C2 and C3 are identical. The elements of C2 and C3 are same, and when we expand this determinant along the first row, we get the value 0. See, this is 3 into minus 4 plus 4. Then change the sign of the middle term, minus 2. Here I have written minus 2, and then this will be 0 plus 1. And the last term is 2. 2 into 0. This is 0 into 4, 0. plus 1. So in this way we get the value and it is 0. So if any two rows or two columns are identical, the value of the determinant is 0. Now this is the fourth property. If each element of a row or column of a determinant is multiplied by constant k, then its value gets multiplied by k. Again consider the same determinant. This determinant value is minus 28. Now when we multiply each element of any row or column by a constant, then the value gets multiplied by that constant. This is the simple property. So now I'm going to multiply the first column elements by 2. C1 changes to 2 into C1. C1 changes to 2 into C1 means first column elements will be now 2 into 2, this is 4, 6 into 2, this is 12 and 1 into 2. Okay, so now I have changed the first column elements. I have multiplied the first column by 2. So these are the new elements of the first column. The second and third column will remain as it is. And now we will expand this determinant. This is 4. 4 into 0 minus 20. Change the sign of the middle term. This is plus 3. Here I have written plus 3 into this 12 into minus 7, that is minus 84, and minus 8. 2 into 4 minus 8. And the last term is plus 5 into this will be 60 minus 0. 60 minus 0. And then after calculation here I am getting minus 56. Minus 56 can be written as 2 into minus 28. So here we have multiplied the first column elements by 2. So the value will get multiplied by 2. 2 into minus 58. This will be minus 56. Okay. So we get this value multiplied by 2. Okay. So this is the fourth property. Now fifth property is if sum or all elements of a row or a column of a determinant are expressed as sum of the two terms. Sum here means addition of the two terms, then the determinant can be expressed as sum of the two determinants. See, I am going to explain using example. This is if the determinant is a1 plus lambda 1, a2 plus lambda 2, a3 is lambda 3. Means these elements of the first row, they can be expressed as the sum of the addition of the two terms. So we can separate this determinant into two determinants, and in the determinant the first row will be a1, a2, a3. Here this is the first row of the first element, a1, a2, a3. Write the second row, third row as it is, b1, b2, b3, c1, c2, c3. Okay, so second row, third row will remain same, and in the second determinant we will write the second element of each term, lambda 1, lambda 2, lambda 3 in the first row. So this is lambda 1, lambda 2, lambda 3 first row, b1, b2, b3 second row will remain as it is, third row will remain as it is. Okay, so we can write this determinant, we can split this determinant into two determinants, and it will be the sum of the two determinants. The first row will be separate, and then second and third row will remain as it is. So this is the fifth. Okay, now property number 6. This is the sixth property. If to each element of any row or column of the determinant the equimultiples of corresponding elements of other row or column are added, then the value of the determinant remains the same. Means what, children? See here, this is the determinant a1, a2, a3, b1, b2, b3, c1, c2, c3. Now if I multiply the third row element by a constant k, and if I add these elements to the corresponding element of the first row, okay, then the value remains same. So we can add multiples of any row to the corresponding elements of any other row. Okay, so it will be positive or it will be negative multiples of that row or column. This can be done column wise also. The value of the determinant will remain same. Okay, that is, if we apply the operations, Ri changes to Ri plus K Rj, this K will be positive or a negative constant. So Ri changes to Ri plus K Rj, or Ci changes to Ci plus K Cj, then the value remains same. Okay, that is, here I have done R1 changes to R1 plus K R3. The R1 first row elements are A1, A2, A3, and R3 elements are C1, C2, C3. Now I will multiply the R3 elements by K constant. Okay, and then I will add all these elements to the first row element. Children, we are changing the first row, so there will be the change in first row element also, elements, and the second row element, third row element will remain as it is. We are not changing R3 element. R3 will remain as it is. We have written this R1, then change will be in the R1 elements only. So multiply the third row element by K and then add the corresponding elements to the corresponding elements of the first row. So A1 plus KC1, A1 plus KC1, then A2 plus KC2 and A3 plus KC3. So we can add the multiples of any row or column to the corresponding elements of any row or column. The value remains same. Here the change will be in the first row only, not in other rows. So the second and third row elements will be as it is. They will remain same. The first row elements will be A1 plus KC1, A2 plus KC2, A3 plus KC3. So all these are the properties of determinants.